This time around, we're going to focus on a couple of elements regarding speakers that relate to that last discussion we had. We're going to talk about this component of a speaker system called the crossover network, and we're going to talk about what really becomes generally a frequency response discussion. So here is the PowerPoint to get us started. We'll start with crossover networks, and the idea of linearity will follow. What does a crossover network do? Basic question. In order to really go forward with this, I would like to bring up a couple of points made in the previous video. First thing is, we've already talked about how a speaker system can involve more than one driver. And frequently the drivers are designed in such a way that they are more appropriate or better capable of reproducing a certain range of frequencies. So we talked about the woofer, primarily focused on low frequencies, the mid-range, naturally focusing on mid-range frequencies, and the tweeter, which is focusing more on our high frequencies. Now, we have to get the signal sent to them in a manner that is appropriate so that the right frequencies get to each of these drivers, and then they're combined to create that sound, to create the acoustic energy that represent those ranges of frequencies. So the crossover network is the tool, it's the piece of the speaker inside that enables it to send the right frequencies to the right drivers. So if we think about a single driver system, it basically has to address the entire range of frequencies from 20 hertz to 20K. And usually that's going to be insufficient. A cone that's large enough to represent some of those low frequencies may not move back and forth fast enough to actually reproduce those higher frequencies. And so it's going to be limited in what it can do in terms of representing sound or providing us with an accurate sound capturing or sound rendering. So what we end up doing is using multiple drivers. In this case, the image is showing us a single driver system and a two-way system. Two-way system is allowing us to split that 20 to 20 kilohertz and send the frequencies that are higher to, in this case, the tweeter, and those that are lower to the larger cone, the larger driver, which we'll call a woofer in this particular case. So the crossover network is going to help us get the right signal to the right location. Now there are two kinds of crossover networks. There's a passive and an active. And so we'll start off here by focusing on what an active crossover network is. So an active network is one in which the signal comes into the speaker, and then it gets amplified as it's being sent to the different drivers. So first it comes in, and then it's split up. Low frequencies will be sent to the driver that is associated with low frequencies, the woofer. Higher frequencies will go to the tweeter. And before they get to those drivers, there's a boost to the signal overall. The signal's amplified. So what's happening here is there's an active increase in the amplification of that signal before it gets to the driver. And essentially all we're doing is filtering out some frequencies that will be best reproduced by the higher driver, the tweeter in this case perhaps, and then those that will be better reproduced by the other driver, which is the woofer for the low frequencies. So that's an active crossover network. The other kind is the passive, and the passive crossover network really works a little bit differently. We're amplifying the signal as it comes in, so it's not being changed once it comes in and gets to the drivers. And then it's just being split. That is, the filtering is going on, splitting the high and the low frequencies, but it's not being amplified after that split. So this is a passive split that's going on, whereas the active crossover network has an active split, meaning it's boosting the signal after being filtered. So this is our passive network system overall. And we have to keep in mind that the crossover is used in order to split up that signal. So if we have a two-way system, usually that split is happening somewhere between 1.5 and 2 kilohertz frequency. So anything at, say, 1.5 and above is going to go to that upper driver, and everything that's below that 1.5 or 2 is going to go to the larger driver to capture those lower frequencies. But if we're in a three-way system, what we end up having is at about 400 or 500 hertz, those frequencies are going to go to the woofer. Between that 500 and about 3,500, those frequencies are going to go to the mid-range. And then above 5 or 3.5, those frequencies are going to go to the tweeter. So our three-way system is got a crossover network that is filtering and splitting up the overall signal to three different outputs, representing the three different drivers being used in the system. So that's our crossover network, and it is giving us an idea of how we are reproducing the full range of frequencies from 20 to 20K using our speakers. So we are interested, just as we were with a microphone, trying to understand how the microphone reproduces signals from 20 to 20K. We have the same kind of concern about speakers or monitor systems. And we want to know, well, let's see, how can we recognize the similarity or the effectiveness of that speaker across those ranges? Well, the first thing we want to understand is, what is the width of that system that is acceptable? So the width of the system is representing what the actual range of frequencies really is intended to be in terms of its reproduction. I always like to think of the difference between a really high quality stereo system and the kind of sound we're reproducing on our phone. So our phone isn't usually designed to be reproducing high quality music. Generally that's not the goal, right? It's mostly focused on voice. And if we want to play music or something else, we send that signal to something that's designed to reproduce wider range of frequencies for us. So our voice-only system might only be covering a range of frequencies from about 100 hertz to about 5 kilohertz. So that's capturing most of our voice frequencies. A full music system would attempt to capture somewhere from 40 to 20,000. So you can really get a sense for the width and how that drives what we're accepting in terms of the way in which this speaker system is developed. Now, width of response covers that range of frequencies. The flatness of response captures that linearity. And so that's where we want to get to this point. So linearity is essentially just like our frequency response for microphones. It's showing us how efficiently a speaker system is reproducing frequencies across the spectrum from 20 to 20K. Here's a SPL versus frequency graph that shows you how a speaker was reproducing a signal starting at 20 hertz and then going all the way up to 20 kilohertz. And you can see the variations where at the very high and very low frequencies it wasn't as effective, but it was much more effective across the middle, across the mid-range frequencies into the upper mid-range and the lower part of the treble frequencies. So just as we were interested in how a microphone reproduced frequencies, we're interested in how speakers reproduce them as well. We just give it a name called linearity. So, quick review. We're interested in the frequency response of a speaker system, and that is going to be enhanced or enabled by something called a crossover network. So that network is splitting up that range of frequencies and sending it to an appropriate reproduction driver. And then we have our width of response, which is going to be identifying what's the range that we really need to reproduce with a speaker system. And then we have the linearity, which is talking about how efficiently the speaker system is reproducing the sounds across that full frequency spectrum from 20 to 20K. So that pretty much sums things up for this particular video. And we'll have more information for you involving phase, because phase is an important aspect associated with speakers, just as it was with microphones. You'll see that in the module as well. And we've got a couple of extra videos that really show you how these speakers are created, how they're made, so you can kind of get a little better look at the crossover network and the drivers themselves. So check those out.